Okay, this is number 21A from Are You Ready for Calculus? And the question is, find the equations of the circle A with center at 1, 2 that passes through the point -2, -1. Well, we have the center if we know the radius, and we can find the equation of the circle. In order to find the radius, we can find the distance from the center to any point. So we have a point. The point on the circle is a -2, -1, and this is the center. 1, 2, so in order to find the radius, that's real easy. We just use the distance formula. This will give us the distance between any 2 points if we know the coordinates. And we know the coordinates, so we can call this point x1, y1, this point x2, y2, and then just substitute in the distance formula. Now remember, this is just derived off the Pythagorean theorem. In other words, if you squared both sides, this would be d squared equals delta x squared plus delta y squared. These would be the sides of your right triangle. That would be the hypotenuse. So that's how you actually find the distance between 2 points. We just substitute this in to find the radius. This is the center, and this is my point on the circle. And then r, which equals d, and then we just substitute in. x2 is -1 minus 1 squared, and y2 is -1 and then minus 2 squared. And that just becomes -3 squared, which is 9, and -3 squared, which is 9, so the square root of 18. And we could simplify that a little bit, but we could leave it like this because we just want to find the equation of the circle. Remember, the equation of the circle is x minus h squared plus y minus k squared equals r squared, where k is the center. So we have the center at 1, 2, so that's my center. So x minus 1 squared, y minus 2 squared, and the radius squared, the square root of 18 squared is 18, so there's the equation of the circle. So that was pretty easy because of the formulas we have. Next one was a little trickier. Okay, the circle passes through the origin and has intercepts equal to 1 and 2 on the x and y axis respectively. Okay, then we know it goes through the origin. So what I do is I kind of sketch it out over here so you can see what's going on. So I'll zoom in a little bit on this over here. And this is my drawing here. Now these are the points on the y-axis. This was the intercept. Remember, it had the intercepts. The x-intercept was 1 and the y-intercept was 2. And it goes through the origin. Okay. Now you have to remember, it's real easy to prove this theorem, but the perpendicular bisector of a chord goes through the center of the circle. Something you're supposed to learn in geometry. The perpendicular bisector of a chord passes through the center of the circle. Well, if we look at these lines here that are perpendicular, this is an axis, so the line that's perpendicular to the y-axis would be parallel to the x-axis. And the bisector, if this is the point 0 and a 2, the bisector would be at 1. So the line that's perpendicular to this chord and goes to the bisector would be this line, y equals 1. So that means that the y coordinate of my center will be 1. And so from the same respect, if I look at the x-axis, the chord that's on the x-axis, the points are 0 and 1 that are on the circle. So this is the chord, and the perpendicular bisector of this chord, since it's on the x-axis, would be parallel to the y-axis. That would be the line. So that's going to give me the x-coordinate of my center, and the midpoint of 0 to 1 is just 1/2. That's how I find the center of the circle. Okay, so by looking at the sketch, this is my perpendicular bisector of this chord, so that goes through the center. This is the perpendicular bisector of this chord, so that goes through the center. So therefore I figure out the center is 1/2 and 1. Okay, so that was kind of tricky to figure out the center. Now once you have the center, let's get back out here where we were at here before. And we have all these points on the circle, but the easiest one to use is 0, 0. So I'm going to use 0, 0 to find the radius. I already have the center, just like in the first problem, so now I have to find the radius. So again, I'll use the distance formula. And here's my distance formula. I guess I can zoom in a little bit on that a little bit there. And remember, x2 minus x1, so I call this x2, y2, x1, y1 root of the 0. So x2 minus x1 squared, y2 minus y1 squared. That ends up just being 1/4 plus 1/5. So my distance was the square root of 5/4. And that's actually the distance from the center of the circle to one of the points. So that's going to be the radius. So there again, I just put that in the formula we had before. This one up here. X minus h squared plus y minus k squared equals r squared. Where hk is the center, so x minus 1/2 squared plus y minus 1 squared equals r squared. And that's the square root of 5/4 squared is just 5/4. So that was the equation. So that wasn't too bad. But again, you just had to remember some of your geometry for that. So I hope that helps.